So we continue from there today. So we continue from the IP address today. So yeah, let me try to share my screen. All right, so can someone confirm if my screen is on? So, like I was saying in the last class, please can you see my screen, please? Someone can just unmute to confirm. Sorry, are you even hearing me at all? You can drop a message or just because I once I go to the next screen, I won't be able to see the message again. You can just someone can just unmute yourself so that's hello guys. All right. So we can continue. So like I said, in our last class, we stopped at IP address, and I told you guys that IP address is actually worked in the network layer. So IP address and IP or internet protocol is actually a numerical label that is assigned to each devices connected to a computer network. So for you to be able to connect to a computer network, you need to be assigned an IP address. So the IP addresses actually serve two main purposes. One of the purposes of IP addresses is it allows us to identify the host of or the host in the computer network. So IP addresses allow us to identify the host of a computer network. So it knows like, okay, this is the main host in a computer network. And secondly, it provides location of each devices connected to a computer network. So in a computer network, we normally have the host. The host is just like the main system that each computer is connecting to. So we have other systems. So it allows us to identify that, okay, in this computer network, this is the main host. So these are other like another purposes of IP addresses is provide the each device is connecting to a computer network. Let's just assume that we want to connect to this website here, which is isecom.org. So for us to connect to this isecom.org, let me go .org. For us to be able to connect to the isecom.org, this is our main host. This is the isecom.org is the main what? Is the main host. So you can see the website here is the main host. But for us to be able to connect to it, we need our own IP address. So the server or the computer main network will be able to identify our own location of like our own IP address. It will be able to resolve that, okay, this IP address is connecting from this so location. These IP addresses have this information about the devices. So and also this isecom.org at its own IP addresses also. Once I go on, let me just open the terminal and let me try the ping command. Ping. Could not resolve. Okay, let me just remove this. So we should be able to see the request. So we'll be able to get the IP address. So like I said in the last class, we have DNS, which is the domain name server. So this is the domain name server, and it's resolving this IP address. Although, well, as time goes on, we'll be able to understand what I actually do here. So I can copy this IP address instead of me putting isecom.org. I can put this IP address and it will result say me telling me that it's unsecure, but let's see. But I believe the IP address should be behind the firewall. Oh, the IP address is not even behind the firewall. So you can see now that we were able to access this website. We're able to access isecom.org with the IP address. You can see that each device that is connected to the internet have their IP address. And for you to name IP address, with just a ping command, you can get the IP address. So I was able to get the IP address. So this is the IP address, which is 216.92.116.13. So that's the IP address of isecom.org. So let me go back to my slide. So domain name are added for human, like we can be able to identify, okay, this is google.com, this is facebook.com, this is instagram.com. But when it comes to IP address, we like it will be very difficult for us to cram 216 that I have here, 216.92. So that is why the reason why we have the domain name server that allows us to resolve the IP address and using a unique name of our choice. So the network does not understand this isecom.org. The server does not understand this isecom.org. The server that actually doesn't understand isecom.org. What does I? But it is the domain name server or the domain name service that actually understand it. Then it's the DNS that resolve the name back to the IP address and tell her that, oh, I want to connect this so device. Like the connection is like this. This is my own IP address. Let me say IP config. This is my own IP address. This is my own IP version 4. This is my IP version 6. So my this is my IPv4. So my IPv4, this is not even my main IPv4. This is for my VM. This is my main IPv4 here. This is my this is my loopback. This is my main IPv4 here. Okay, this is my main IPv4. This is my main IPv4. So I can be able to connect. So the moment I type isecom.org, what's happening in the server is the server will now tell them that, okay, the server will now go back to the domain name server and tell that and resolve the IP address. It's now telling that it will now connect to this IP address and telling the IP address that, hey, this IP address, so IP address from this location with the device, like my device information also will be there, wants to connect. Do you want to accept the connection? So if he wants to accept the connection, and if it doesn't want to accept the connection, it will be unable to accept the connection because the location of my IP address is already going along with my request. So as my with my location going along with the request, it will understand that, okay, you are connected from Nigeria. So let's just assume that isecom.org does not accept any IP address from Nigeria. I won't be able to access it because my location of my IP address is there. That is why I said that IP address as service to purposes. It allows us to identify the host, which is this. This is our host. It allows us to identify the host, and it's provide location of each devices. So my location, you can see now that it was with IP addresses. The other time when Twitter banned Nigeria from accessing Twitter, it was through IP. No, it's not even Twitter. Like it is Nigeria banning Twitter from from giving access to Nigeria. So it was through the IP address. They were like, okay, so IP address, because as we in Nigeria, we have our own range of IP addresses. So if Twitter is asking, like seeing that IP address, it will not telling them that you don't have access to Twitter on this location. So it allows us to identify the location of each host and identify the host and provide the location of each devices. And we have two types of IP addresses. We have IPv4 and then we have IPv6. But our focus for this bootcamp will be on IPv4 because that's the most common used. And although we started using IPv6, but it is not that common like IPv4. So, like I said last week, also like IP addresses like are like street addresses. If you want to mail, you have to have one. Like if you want to connect to the internet, you need an IP address. If you want to have a network, your own personal network, you need IP addresses. So you understanding the concept of IP addresses, it will be very easy for you to set up your own like so own lab at home and have multiple devices connecting to your lab. So IPv4 consists of 32 bits and that are divided into 4 bits in octets. Like we have 32 bits in 4 8 bits. So this is what it means. Like this IP addresses, right? This IP address is 4 octets. This is octet 1, octet 2, then another dot, octet 3, then octet 4. So you see all of these IP addresses are 8 bits. What does the 8 bit mean? That it means that we have 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. So this is what the IP address actually means. This is what they mean by the 8 bits. So each of these octet has what? Has 8 bits. Each of the octet has what? Has 8 bits, and they are in binary actually. They are in binary. So if you can actually convert this back to the normal octet, so this is what even the computer is actually understanding, because the computer actually understand one uh 0 and 1, which is the binary. So this is exactly what it is now transforming into this octet. This IP addresses now will be 0.0.0.0, right? Because it's 0 or true. So that's what it mean by the octet, which are separated by dot. They are 32 raised to power 32 bits. So if you actually count all of these bits, here, we have another 8 bits here. We have another 8 bits. So 8 bits plus 8 bits give us 16, plus another 8 bits give us 24, plus another 8 bits give us 32. Then we have 2 raised to power 32. Then if we set 2 raised to power 32, we have 4.2 billion IP addresses on the internet under IP version 4. Like for IPv4, we have 4.2 billion IP addresses that are available. So these are the number of the IP addresses that are available, and the remainder of the IP addresses identify the individual computer on the network. Think of this part as the country or city. From these IP addresses, that's where they generate that, okay, for Nigeria, you should have these very IP addresses if you are connected to the internet. So if you send IP addresses that start with some specific number, it's under like it's resolved that, okay, this is IP address coming from Nigeria. That is where the shared IP address for each countries. So imagine we are more than 4 billion. We have more than 4 billion individual on the earth currently, and they said we have 4.2 billion IP addresses. So and if you have a phone, your phone has an IP address. You have a laptop. Some people even have more than 2 phones. So how does it possible that the IP address version 4 does not, like, they are not they are still available? Why are they not unavailable? They should have, all of them should have been acquired. Yes, all IP addresses can v4 can never be finished because we have something that is called subnetting. So with the help of subnetting, we can have more than 4 billion IP addresses. So I'll be explaining that later in this slide. So you can see 8 bytes, 8 bytes, 8 bytes, 8 bits, sorry, 8 bits, 8 bits, 8 bits, 8 bits. So it's which resolve to 1 byte. So we have 4 bytes. So this one has, each octet has 8 bits, which makes everything 32 bits. Then 2 raised to power 32 will give us. Then we have the network address, and then we have the host. In every IP address, in every devices or in every networking connection, we normally have the network, and then we normally have the host. So they said there are two they are both public and private IP address. So we have public IP addresses, and then we have um, private IP addresses. So private IP addresses are used by private organizations. So the IP addresses that is no more available nowadays is the private IP addresses, because those private IP addresses have been bought by top organizations. So there is no more private, they are still public IP addresses. So it is this private, from this organization that have already bought the private IP addresses. It is from them we now go on and buy our own IP address that we can actually be using. So IP address within a private network should not be duplicated within that network, but computer will do different. So this actually means that private network will have same IP addresses. Like we can have same addresses, but our connection will actually be different. So let's just get started with what the classes of IP addresses. So from there we can know what private and public IP. We have class A down to class E, but the common one is class A to class C. So IP addresses is zero starting from 0 to 230, 250, from 0 to 255. So from 0, each octet starts from 0 down to 255. So once this got into 255, it will move to the next one, 0 down to 255. So from there, you can be assigning different IP address to yes, you can be assigning IP address to different computing devices that wants to connect to your network. So for the class A starts from 0 down to 171, 0 down to 171. Then we have class B, which starts from 172 down to 191. Then we have class starts from 2. Okay, they actually explain it in deep here. So the first bit is always 0. So the first class, like, okay, let me go up. I wish we are in a class so I'll be able to show this properly. I don't have notes, but if you actually go through this PDF that I sent, it's very understandable and it's very straightforward. So, but our own goal is just for us to understand that, okay, this is class A, this IP address is class B, this IP address is class C. So from 10 down to 170 what? From 10 down to 171. From 0, sorry, from 0 down to 171. So if any IP address that you see that the starting point is from 0 down to 171, just know that that IP address is for class A. Then if you see any IP addresses that start with 191, just know that that IP address is class B. So if from IP addresses starting from 192 down to, I've forgotten, so 192 to 223, 192 to 223, just know that that IP address is class C. Then from 224 down to 239, that is class D. Then we have class E, and yeah, but class E is not actually explained here. So the class E is just more of like our Ethernet network. So that's class E. So class E starts from 240 down to 255. 240 down to 255. So whenever we see an IP address, sorry, I made a mistake earlier. So IP address of class A starts from 0 down to 127 or 126. Yes, it starts from 0 down to 126. Then class B starts from 128 down to 191. class C 192 to 223, class D 224 down to 239, and class E starts from 240 to 255. Then we have an IP address that is called our home network, or we call it look back network. So it is assigned to each devices. If you bought your device, you definitely see it. It is called the local host or the loop back network, which is this very IP address is, which is 127.0.0.1. If I copy this IP address and I paste it .1, I don't know, maybe it will resolve in Windows, but let me go back to my Linux. Should be able to resolve in my Linux. So you're unable to connect. Let me just, I don't know what's wrong with Windows, but although if you are working on some project, it's usually resolved, but it's usually resolved on the Linux. So before my Linux come up, finally, let's go ahead. So we have the loopback IP addresses, and then we have what is called the MAC. We have what is called the subnet max. So subnet max is, we said the class A starts from what? One starts from 0 down to 126. So the subnet max of 20, like the subnet max of class A is 225.0.0.0. Then for class B it's 225.225.0.0. Then for class C is 225.225.225.0. What does this mean? This actually means that, so for this IP address, so only for this class A, we can have over, it should be 2 raised to power, let me see, 2 raised to power 24. So the devices we can have in, let me use calculator from here, 2 raised to power 24. In total we have 4.2 billion IP addresses. But for class A, we can only have 16 million IP addresses for class A. We can only have 16 million IP addresses for class A. They're moving down to class B. We have 20 here, and we said that each octet is what? Each octet is 8 bits. So for class B, we should have 2 raised to power 16, because we have the IP address will occupy these two. So getting down to here, you can start sharing from this point to this point, which will be the next 16 bits. So the next 16 bits for class B is, so for class B, we can only have 65,000 IP addresses, and then, which is raised to power 8. Then we can only have 256 computer that can be connected to a class C IP address, and then they have 65,000 plus computer that can be connected to a class B IP address, and we have 6 IP address computers that can be connected to class A. So we add everything together, which will be 2 raised to power 32, which make us to have 4 billion IP addresses. So what does it mean to identify a host? You need both the IP address and the network mask. So the network mask actually helps us to identify the main host in an IP addresses. Although we are not going deep on this, because we just want to have an overview of IP addresses And I've already told you guys that IP addresses, the host is like more of like what I did with isecom.org. Let me see if my Kali have opened. Okay, my Kali has opened. Let me open the browser. So let me ping now from here. Let me copy this and ping it. Ping. So I need to remove this. So you can see the IP address doesn't change. So I can simply copy the IP address from this point. So it's asking me advance. So you can see I even tested with my Kali and it works perfectly. So what I want to do is I want to see my local host on my Kali. So I say 2127.0.1. Okay, .0.1. So it might not go. The reason why I said it might not go is I need to turn on my Apache. So I need to on my Apache. So I don't actually know how to turn on the web server because Kali actually helps us like it's allow us to have our own web server. So I said sudo start Apache 2. Oh, I've just changed the command. Okay, sudo service Apache 2. Okay, let me see. Let me just Google how to turn Apache server in Linux. Start and stop. But I don't know why it's okay. Sudo service Apache to start. All right. Sudo Apache to start. So the Apache server we started and let's wait for it. So if the Apache have started, I can be able to see my 127.0.0.1. Yeah, you can see now that I was able to resolve this. I was able to resolve. And if I could check my host devices, if I could check my host devices, okay, sudo nano etc host. Okay, it's not even there. But if I go to this website that I actually like, it was because I turned on Apache, and Apache already have the vault page, and that is where um, Linux actually help us to host our local host, help us to yes, have our local host. So I can access where these devices can see the file. You should replace this file located at www.html index.html. So that's where this is the part where they hosted this very page that we can be able to access. And it was because we turned on Apache, that is why we have it. So automatically Apache server is running on Linux, but it's not running on Windows. That is why I need to set up the Apache, but it has already been set up for us on Linux, so it's very easy. So let me stop my Apache server. So if I stop it and I try to reload this, I won't be able to access it again. Okay, it hasn't stopped yet. Okay, it has stopped. You can see unable to connect because my Apache server has been turned off. The power of every devices. You can even try it out on your own Kali. So every devices have its own loopback IP address, or sometimes they call it home network. So they call it home network. So we have the network addresses, and we have the broadcast addresses. So the broadcast addresses is basically the part of the network where the host would part would be. So it is what they use to send messages. The broadcast addresses is what they use to send messages, and it is being strictly identified with the subnet marks. So if it is in a subnet, if it is class B, this is a class C IP address. No, this is a class B IP address. Actually, this is a class B IP address. So if it is a class C IP addresses, coming. Yeah, that is a class B IP address. This is a class B IP address. You can see this. So the 255 will be at the end, so that it will be using to broadcast. So you can actually read more about all of this networking, because if we actually go deep into the networking, we won't be able to have privilege to do whatever he wants to do. But we should just have it at the back of our mind that we have what is called IPv4 and we have what is called IPv6. So the main purpose of IPv4 is for us to identify a network, identify the host of a network, and providing the location of each devices connecting to the connecting to what, to the host. So we have ports. Like I said, we have over 65,000 ports available on the network. So if you could be able to identify a network, if you could identify a network, like if you could identify an IP address, sorry, if you could identify an IP address, so with the port number, so the port can be either a TCP or a UDP, which is the Transmission Control Protocol, or the User Data Can Protocol. So it can either be either of these two. So it's used to exchange information with applications. So we have so many ports, but there are some reserved ports that are being used for normal services like the HTTP server. You can see we have 65,535 port numbers available on so you can see now that we have this. So let me just so ESECOM. So this is their IP addresses. So let's even see. Let's try to scan these IP addresses and see. So we get to get familiar with it. Yeah, but I just want to use it to show you what the port number is all about. So I can use mmap sudo m mmap. So let me just paste the IP addresses here. So let's see available port that is open on this network. It might took a while before it has scanned. So mmap is a tool that we normally use to scan for port. So when we get to the stages of ethical hacking, we get to familiar with the scanning tools. So it's giving out on port because of the transmission cap it too. So they're trying to block some requests, but let's give it some minutes. So let's see the available port that is open. So on the norms, we have different ports. So these are normal ports that is common. So we have five, port number 5, which is remote job entry. We have 7, which is echo. So the main one that we normally use is the 2021, which is the FTP. So FTP is a port that we normally use to transfer file from one computer to another computer. So once you know the IP address, IP address of a server, and you could identify that this port 21 is open, you can actually connect to that IP address with the FTP. And sometimes it might require some username and password, while sometimes it might require some anonymous login. Either way is fine. And then we have the SSH. The SSH is actually common on Linux machine, so which is the secure like secure shell. It is called the secure shell. So it is used to connect to a system remotely. So once you connect through the SSH, you have access to every file and every information on that system. So if you're actually connecting to an SSH, so it might require some password, it might require password and username, and sometimes it might not. So depending on how they set up the server, so SSH, we have the telnet, we have so for simple mail transfer. So port 25, if you actually want to send mail across, even using your Google and everything, this port is actually open on your computer. If this port, even this port is open on your phone, if this port is not open, you won't be able to send mail. So we have RLP, Resource Location Protocol, name server. We have the 53, which is for the domain name server. Then we have the 80, which is for the HTTP, which is for the web server. And then we have the 443 also. 443 is not here. We have the 443, which is for HTTPS secured. So now moving down to, we have some assessment here. So moving down to this part, I've already explained this part in the last class. So we have the OSI model, which is the application layer. We have the presentation layer. We have the session layer. We have the transport layer, network layer, and then we have the data link, and then the physical layer. So the application layer is just more like the device, like this browser that I'm using to access this website. So that's the application layer. So the presentation layer is where the encryption actually occurred. It is actually explained here. So they are responsible for direct interaction between the application user interface to the application. For instance, the use of a web browser like Firefox, File Explorer. So responsible that the presentation layer is actually responsible for, like, okay, we are sending a file across the network. So the encryption, it allows you to, because if you are let's just assume that you are sending an image over a network. The computer does not understand what is inside the image. So the computer will break the image down into what it understands, which is the binary. Then it tries to encrypt it so that whenever someone else intercepts that request, it won't be able to get the actual information. So that happened at the presentation layer. Then we have the session layer. So the session layer is where both the sender and the receiver, they establish a connection that, hey, I want to connect with you. And then the receiver will say, okay, yes, I'm ready to connect with you. So the session layer is where both parties, both the sender and the receiver, they set up a session where they can actually send and receive, and they terminate the transport layer. So the transport layer is where we have the TCP and then the UDP. So it's transport layer provide the transparent of the data. So if you are using a TCP connection, just know that the connection is reliable. Everything you are sending, you are getting it exactly. But if you are using a UDP, you might get a breakdown along the line. So that's the difference. So connection, TCP is reliable while UDP is unreliable, and it happens at the transport layer. And then we have the network layer. So the network layer is where we have the IP addresses and the MAC addresses, so that whenever you'll be able to identify the host, and also after identifying the host, the host will also be able to identify your own location. Okay, this is where you are coming from, this is exact. So we have the IPv6, and then we have the IPv4, and we also have the MAC addresses. Then we have the data link. So the data link layer is the next to the physical layer. So basically, it's a prepared encapsulation of the data so that it can be transmitted over the physical means, such as the radio waves, fiber optics. So the data link is where we have the cable, or we have the wireless connection actually. So we have, so the data link is where we have our devices like the fiber optics, the cable, the copper, and everything that we use to set up our connection. Then we have the physical layer. The physical layer is what we see, like where we have our switch, where we have our hub. Even though I said when I want to define what a network is, I said a network is just two devices trying to send files across each other through either in a wired or a wireless connection. Even in a wireless connection, we have wired, because the switch and the router have been set up in a place that we're able to access it. We are just accessing it remote. We are just accessing it wirelessly. So that's why we are accessing it wirelessly. There is a dedicated space where we have the server, and that's where we have the physical layer. So that's about the 7 layers of the IP of the networking, which is basically the open system interconnection OSI model. So I guess that will be all for today. Yes, that will be all for today. So if you have a question, so question, I'll stop sharing my screen now.